Introduction to breadboard. A breadboard or plug board is a testing board used for testing of circuits. It is a simple plastic board which is wired from inside in a particular manner, and you can test circuit comprising of ICs, resistor, capacitor and many other pin devices by just plugging it inside the holes. A breadboard is a temporary circuit board for testing and prototyping circuits. No soldering is done, so this becomes a faster and easier method to build a prototype. Since it requires no soldering, it is reusable. Breadboard holes are vertically shortened. This is the anatomy of a breadboard. There are four parts, that is, the binding post, the DIP support, the power rails and the terminal strips. The terminal strips. Once inserted, that component will be electrically connected to anything else placed in that row. This is because the metal rows are conductive and allow current to flow from any point in that strip. Notice that there are only 5 clips on each strip. This is typically on almost all breadboards. Thus, you can connect only 5 components connected in one particular section of the breadboard. You'll also notice that each horizontal row is separated by a ravine or crevice in the middle of the board. This ravine isolates both the sides of a given row from each other, and they are not electrically connected. Each side of a given row is disconnected from the other. The power rails. These power rails are metal strips that are identical to the other ones that run horizontally, except they are typically all connected. When building a circuit, you tend to need power in lot of different places. The power rail give you lots of easy access to the power whenever you need it in your circuit. Usually, they will be labeled as plus and minus and have a red or blue or black strip to indicate the positive and negative side. It is important to be aware that the power rails on either side are not connected. So if you want the same power source on both sides, you will need to connect the two sides with some jumper wires. Keep in mind that the markings are there just as reference. There is no rule as to you have to plug power into the positive rail and ground into the negative rail. The DIP support. Many ICs are manufactured specifically to fit into breadboards. In order to minimize the amount of space they take, the breadboard they come in what is known as the DIP. These DIP chips have legs that come out of both sides and fit perfectly over that ravine. Since each leg on the IC is unique, we don't want both sides to be connected to each other. That is where the separation in the middle of the board comes in handy. Thus we can connect components to each side of the IC without interfering with the functionality of the leg on the opposite side. Rows and columns. There are many breadboards which have numbers and letters marked on various rows and columns. These are just to guide you. Circuits can get too complicated quickly, and all it takes is one misplaced leg of a component to make the entire circuit malfunction or not work at all. These are the helpful instructions, such as the one found in this electronics tinkering kit. Many books and guides have circuit diagrams for you to follow along while building your circuit. Just remember that the circuit you are building doesn't have to be in the exact same location on the breadboard as your book. You can do it the way you like. Binding post. Some breadboards come on a platform that has binding post attached to it. These posts allow you to connect all kinds of different power sources to your breadboard. Providing power to a breadboard. When it comes to providing power of the breadboard, there are numerous options. First, borrowing power from other sources, example a 9-volt battery. If you are working with a development board such as Arduino, then you can simply pull power from the Arduino's female headers. The Arduino has multiple power and ground pins that you can connect to the power rails or other rows on a breadboard.